Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is cyclobutane with an isopropanol group attached. Cyclobutyl C, CH3, is equal to CH2. More precisely, one carbon of the cyclobutane ring bears a substituent C, CH3, is equal to CH2. Moving on to the next step. H plus adds to the terminal is equal to CH2, less substituted carbon, generating a carbocation at the internal carbon, cyclobutyl C plus, CH3. This tertiary carbocation is adjacent to the cyclobutane ring. Moving on to the next step. The carbocation formed, cyclobutyl C plus, CH3, has a tertiary carbon cation adjacent to the strained cyclobutane ring. A 1,2 carbon shift, ring expansion, occurs. One C to C bond of the cyclobutane migrates to the adjacent carbocation, expanding the 4-membered ring to a 5-membered ring, cyclopentyl cation. This gives a tertiary cyclopentyl carbocation, specifically 1-methyl cyclopentyl cation. The methyl and the ring carbons rearrange to give a tertiary carbocation on the cyclopentane ring. And for the final step. After ring expansion, we get a cyclopentane ring with a tertiary carbocation bearing a methyl group, 1-methylcyclopent 1-vial cation. Br attacks the tertiary carbocation to give 1-bromo 1-methylcyclopentane. But looking at option A, it shows a cyclopentane with Br at 1 carbon and a methyl at an adjacent carbon. Re-examining, the cyclobutane ring expansion from cyclobutyl C plus, CH3, gives a cyclopentane ring where the cationic center retains the methyl group, yielding 1-bromo 1-methylcyclopentane as the ring expanded product. Option A depicts a cyclopentane ring with Br and methyl substituents consistent with this ring expansion product, making it the major product due to the relief of cyclobutane ring strain and formation of a more stable tertiary carbocation. B would require a different substitution pattern. C and D are cyclohexane-based products requiring a 5,6 ring expansion, which is not favored here since we start with cyclobutane. 4-membered ring expanding to 5-membered is favorable. No further expansion to 6-membered is the major pathway. Therefore, the correct answer is A. Therefore, the correct answer is option A.